So this is the 2009 examination. I'm going to go through reading time with you. At the beginning of each question, I recommend I'll give you 5 seconds to pause it and kind of look at it, and then I'll start running through it. Okay. So pause now if you feel like it. Okay, he's a mass of 80 kilos, running at a speed of 4 meters per second. Steps on a stationary trolley of 40 kilos. So that's 40, he's 80. And just holds the trolley. Ranjiv and the trolley then move forward together in the same direction. What is the speed of the trolley? So this is a momentum question because we have mass and velocity, and we have a number of mass, and it's a collision. Basically, it's a collision. And when you see collision, think momentum or energy. Okay, so we can solve that like that. It's a collision of an elastic or an elastic. Justify with calculation. So, as we said last time, elastic means that all energy is conserved. So all we need to do is find the energy before and after with half mv squared and see if they're equal. If they're equal, it's elastic. If they're not equal, it's inelastic. Circle radius 100 meters. So there's a picture down here. So we'll see if we can translate all this information to the picture. 500 traveling at a constant speed of 32 meters per second. The motorcycle would ride has a mass of 250 kilograms. I'll let you read it now, actually. Okay. 100 meters, velocity is 32, massive. What is the magnitude of net force? F equals mv squared. Because it's traveling in a circle, that has to be the only force. Yep. Or the net force. Draw an arrow to show the direction of the net force on the motorcyclist. So it always goes inwards. And that's pretty simple. So this one, spring question. Thinking half kx squared and kx. F equals kx. Anyway, I'll let you read it for now. So what's important? Ready? A block of mass 0.2 kilograms, compressed by 10 centimeters, that's important. Block is released. So it's compressed and released. And the spring, when the block leaves contact with the spring at point B, the block has a speed of 5 meters per second. So, as we said, what is the spring constant K of the spring? So the only piece of information we have about this block is that about how much energy or anything about this block is that this is 5 meters per second when it leaves. So how do we convert velocity into spring, into K? We can convert that by energy. That's the main way to convert from different types of things here. See on my cheat sheet, energy can go from kinetic or gravitational or spring or work, and they're all the same value. So basically here we're going from kinetic energy and saying that was the spring energy. Oh, whoops. Sorry about that. My iPhone is sagging a bit. Okay. Okay. So that's it so far. So we get velocity coming off here. We get half mv squared equals half kx squared. Cool. This point C, the block still has 5 meters per second. Point C, because rough surface provides constant friction force. The distance from C to D is 2 meters. What is the magnitude of the friction force? So here we're converting energy again from half mv squared into work, because that's friction or force going in the opposite direction. So what is the magnitude of the friction force? We know the distance is over 2 meters, and we know it has a certain amount of energy, half mv squared. So we just go half mv squared equals force times distance. Or we take the energy from the velocity and divide it by the distance to give us force. Okay, next question. Alright, means on a free fall, attack, blah. So, when it's a long thing and you're in reading time, you have to get through it really quickly. Just find out what's happening. Net. So it's something being dropped and it's called by a net. And This platform is moving upwards by 5 meters per second. What is Helen's apparent weight as she travels up? So what you do is, the apparent weight is the normal force of this. So normal force minus mg equals acceleration, equals the total force. But we know there must be a net force going upwards, so it equals 5. A bit hard to explain, but come back and look at the question afterwards and I'll show you how to do it. But we know that's a force question, so I'm comfortable with that. Slows down. Okay, so another force question. Now it's slowing down, so the acceleration is different. On this side, we just realized that she was not accelerating, so her apparent weight would be normal, or would be her usual weight. During a fall, apparent weightlessness. Apparent weightlessness is different from true weightlessness. I won't go into all the details, so I'll do it on the question later. But essentially, apparent weightlessness is when you have no normal force. That's how we know we weigh anything. So this is a projectile motion. If you feel comfortable with projectile motions, you can just be like, okay, it hits the ground. Now remember, if it hits the ground, if we want to find time, we usually have to go with vertical first. We have to look at the vertical component. So we have the u, we have z, what else does it say? How above the cliff does the ball rise? So here we have u, we have acceleration, and we can find out how high it is above the ground. And then we get t. I'll explain it later, but we're pretty comfortable with projectile motion questions, so I can kind of skip looking at it for now. On a loop-to-loop, has a radius track of 7, so I'll let you read it. Okay, so this is a circular motion question. I'm going around a loop-to-loop. There's a formula for that. Essentially it is mg equals mv squared on r. Because here, if there is no normal force, if it's just touching, then the force inwards is only gravity. And we know that has to equal the centripetal force. Okay, this is a gravity question. You can ignore, draw, and you says it orbits Earth. So, again, it's moving in a circle, so the force must be going inwards. And that must be the net force. Yeah, and Earth is the only force there. What is the period? So, we're given the mass, we want to find a period. All we need is some way to convert mass to period. And here it is. We just sub it into this thing, and we get that thing. We just have to rearrange it to get the right answer. Okay? Not too hard. And we're on to electronics. So 8 minutes with some explanation. So you should be able to do it faster than that. But that's roughly about what you need to be thinking and what you need to be like doing in your head. It doesn't have to be as in-depth as that. But you just need to kind of get an idea of what each question is and like the beginning of how to do it. Okay, great.